Okay, so we will continue with your opportunities to, I don't know how you want to state that, if you want to wrap up loose ends, or I don't want to say relearn, if you want to say recalibrate, I guess that's a good way of looking at what we've learned this semester. Probably refresher is probably, or refreshing, not refreshing, but a refresher as an example is probably the best adjective we could give. That being said, okay, when you look at that periodic table, what is the most important aspect probably in each element box? What specific number? Okay, so the atomic number is probably the most important aspect of that. So using your vocabulary, someone give me an example of an alkaline earth metal. That is a transition metal.
Potassium.
Radium.
Potassium is an alkali metal. Magnesium is an alkaline earth metal. Okay, so with that being said, what is the symbol for magnesium?
Mg.
Okay. So when you look inside magnesium's box, okay, here is your symbol. What other numbers would you see in there? Okay. So, for instance, I don't know where it's written, +2. What else would you see inside of there?
12.
Yes? Oh, I thought someone had asked a question. No. Okay. And then there's one more number in here possibly.
24.3.
Okay. So we're just going to say 24. What is everything that you can tell me utilizing these three numbers when it comes to this, and that?
Protons, neon.
12 protons,
Okay.
12 neutrons.
So which variable is protons?
The P.
Okay. That's axiomatic. You think P for protons. Neutrons, how many are there?
12.
And how would you get 12?
Because there's 12 protons.
Okay? Now, if we take this into consideration, this is a trick question. Don't go with your first impulse. If you utilize that number that we put in a box, how many electrons does it have?
10. 10 electrons.
I hear 10, I hear 12, and I hear 24.
14.
I think 14.
10.
I'm going with 10 because it needs 2 more electrons to be stable.
I think
So
I had two
we've
extra
heard
protons.
this, we've heard this, and we've heard this.
Oh, no, it needs to give away. Oh, it's 14.
I knew it.
I said it first.
I said second, so I got second, you got first.
No, you copied me. I win.
You want to go in. You guys don't have any in my backpack.
I knew it.
Dang it, that's so bad.
Okay? You can use the Bohr model to answer that question for you. Okay? Because inside of here, we said there's 12 protons. Okay? We're not concerned about the neutrons because those really just give that its mass. That came later when you were adding together atomic masses. So then, utilizing your slide rule,
1.
2. 2.
so first energy level,
2.
then what?
2. 6.
A new energy level.
2. 6.
2. 6. A new energy level.
No.
Yep.
Yeah. 2. 2.
Okay? Now, if we put this 2 here,
Exposed. Hooray.
it would be 12.
Oh my God.
That means that the negative charges have canceled out the positive charges, which means you add those two numbers together and you would get what?
21. 24.
24.
No,
22.
no,
12 plus
No.
22 was 24.
you're going to say, I knew that.
36.
No,
0.
124.
How does that
someone said 0.
Oh, because one's negative
Okay? Because this inside there are 12 positive charges. Okay? And if we say there are 12 negative charges, what happens when you add those two together?
It becomes 0.
You get a 0 net charge. But back to our original question. We said, what if we wanted that for a charge? Because we put that in a box. That must mean that how many valence electrons does magnesium have? And besides looking at this, how else could you say or convey that information to somebody else that it has 2 valence electrons?
By looking at where it's located.
Why is its location going to tell you that?
Because it will tell you.
Because it's in the second column. That's why we had said we want an alkaline earth metal. And if we say lithium, sodium, potassium, rubidium, francium, all of those are alkali metals. Did I say lithium? I think so. Then if you say beryllium, magnesium, calcium, strontium, and barium, and radium, those are alkaline earth metals, which means they're in column 2. So the key is it's in column 2. It's got 2 valence electrons. So if that is going to donate or give those away, now what happens when you add these numbers in coinciding with that one? Because how many do you have outside?
10.
And what happens when you add those two together now?
You get 2. Wait.
So this now matches that. Correct? Using your algebraic skills. All right. So what would be an example of any type of ion that would have a -1 charge or a -2 charge? Pick anything that you would like to see. Oxygen? Does it have a -2 charge?
I think so.
Possibly.
If you try hard enough.
Yeah, it does. I think so.
Yeah, it has a negative 2 charge.
Okay, so it's got a -2 charge.
Thanks, fellas.
All right. So what would we call this? Magnesium what?
Oxide.
Okay, it's not magnesium oxygen. It's magnesium. I can never remember if there's 1 or 2 S's. Potassium and looks like there's 1 S. Potassium's got 2. Magnesium's got 1, I believe. Magnesium, don't say oxygen. Okay, it's oxide. So if we take this content, okay, let's go ahead and put these two back in here. Now let's do oxygen's Bohr model. What's inside the nucleus for oxygen?
8 plus -2.
Okay, so the first energy level,
2.
second energy level,
2, 6. Wait, no, 2.
4.
I hear 2 and I hear 4 and I hear 6.
4.
Okay, so what might be human nature telling you to put a 6 in there? Because it can hold 6. Okay, that is, remember we had said you've got to be careful when you're doing this. You can put those numbers in if you want, but the moment you perhaps lose concentration, you look at this, you're probably going to put a 6 in here too. Okay, so I think it's pretty fair to say losing a lapse in concentration, maybe stepping out of bounds while we are playing football, basketball, or in marching band, or when we throw the volleyball up and we are about ready to serve it, you I have a lapse in concentration, and maybe it turns out all right. Maybe it doesn't. Okay? But that's what can happen here. So now, if you add these numbers together, do they balance this out?
Yeah.
They do. We have 8 inside the circle, and we've got 8 outside the circle. Now, what is everything that you can say about the element oxygen now? This was one of them. What else can you tell me about it?
-2.
Okay, we'll put that up here. And then there should be one more number. Okay?
16.
So, how do we get from this number, which is 8, okay, 8 on the inside, how are we going to get to that?
-4. Wait.
What is it that we would add to this to get a -2? In other words, 8 plus our negative charge of electrons equals a -2. Okay? -6? In other words, how many more electrons would we have to have? 2 more. That's right. So that matches that charge then. Okay? Because if we just leave this as neutral, what does that add up to?
0.
That adds up to 0. But if we make this 10, what does that add up to? And that's what we're looking for up here. But we still only have 8 out here. Where are those 2 going to come from? We can get rid of this now. So if we're doing the dot diagram now, how do we proceed forward? What goes in the middle? Metals or nonmetals? Metals or nonmetals? Yes, yes. It depends how many you have, but since this has a greater number of electrons, we're going to start with oxygen. And what column is oxygen in?
6.
Now, typically, you can keep these electrons together. If you wanted to do this, where are those last 2 electrons going to show up for that oxygen?
A different.
What element would that be? They only have one choice.
Magnesium.
And how many electrons can magnesium give away? 2. So if these 2 disappear, like we've illustrated here, that forms a +2 charge. So if we're going to form a bond here, there's 2 different ways we could illustrate that. Either this, we could say that that's correct, or do that and that. Okay? This is probably a little more accurate than that on the right,
You can only do magnesium, not anything else.
because that's what we chose. But that's if the element has a -2 charge. Is it possible to do that with an element with a -1 charge? And if there was an element with a -1 charge, where's the most likely place you could find them? I hear first column? Is it halogens or first column? Okay, so where are halogens found on the table? Okay, so we can still leave this up here. So what is an example of a halogen? Okay, so it's not what we would have picked, but that's fine. It's just good practice. So some predictions that you can do for bromine. It's element 35, right? I think. Okay. So, first energy level. Second energy level. Third energy level. Okay? Now what?
Fourth energy level.
4s.
2. And then you go back to the third one and it's 2.
Now, when you go back out to here, what column only in the P block is bromine in? Okay? So, why are these two numbers significant? 2 and 5. What happens when we add them together?
Because they're valence electrons, which
Add them together. What do you get?
7. And that's why
What column is bromine in? Okay, so these are these repeating units that we see over and over again. Okay, so how many positive charges how many negative charges does bromine actually form? Just only a -1. Because, remember, how many electrons can the P block hold?
6.
I hear 7, I hear 6, and I hear 8. How many columns are in the P block? There's only 6 columns in the P block. And we've established how many? So it can hold one more. So if it gains one more electron, what charge would bromine have? If it gains one more electron.
It would be stable.
Plus 3, plus 5.
Plus 0.
If we have 35 positive charges,
It would be called.
and if we have one more electron, what's 35 plus 1?
36.
What happens when you add those two numbers together?
You get -1.
You get -1. Okay? So, if we were going to do magnesium bromide now, okay, we've already established magnesium forms a what charge?
Plus 2.
So how many valence electrons does magnesium have? Okay, so would we possibly put these two electrons together like this? The answer is no, because this will answer your question. We don't need the Bohr model anymore either, because this will answer your question. This is -1, that's +2. Does that add up to 0?
No.
Okay, what's the least common multiple?
2.
Okay, so what's 2 divided by 1?
2.
What's 2 divided by 2?
1.
And we've got 1 there. So that must mean we need 2 bromide ions, which would be correct. So if this has 2 valence electrons, would we keep them together? Someone said split them up. That's correct. Who said that? That's right. Split them up. One on one side, one on the other. Okay? Yes, ma'am. So then, again, what column is bromine in? What column is bromine in?
I got it.
Okay? So how many valence electrons is that?
7.
Remember when we had a box there, 5 and 2 gives you 7, so that's where that 7 comes from. If that's what you do on one side, sorry, what's that?
This is just a lot more confusing than it was before.
How is this
This is more confusing.
So we're doing.
We're probably just going faster. That's all.
No, we're done.
You're just doing a lot of more work than I would have done.
Okay.
Yeah. So basically, we're doing.
I would have just done more.
Yeah, magnesium and bromine.
So can we put another bromine here? I mean, we've got 2 of them to account for.
Yeah, magnesium's giving away 2, and bromine's only missing 1. So it's good.
Wow, you are
1 to both of them.
So magnesium